for people to come through the lobby, make sure everything's okay. In the meantime, if you wouldn't mind just turning your camera off and your microphone off, that would be great. And just to let you know, we'll be recording the session. In fact, recording's just started, so that's great. I'll give it just a brief while, and then we'll start up, if that's okay. Okay, it looks like everyone who's coming in has come in. I'm sure we may get some coming along later. So welcome everyone to this afternoon's session, and I'm going to share my screen. If I can, bear with me. So this afternoon's session is all about the future of clean energy. And particularly with reference to activities that are taking place within the South Wales Industrial Cluster. As I say, just to repeat those house rules if we can, if you wouldn't mind keeping your cameras and microphones off, that would be great. However, I wouldn't mind if you have questions, be grateful if you could put those in the chat. We'll sort of moderate those. Probably the best thing would be that we'll save those questions for the end of the session, but we'd welcome any questions that you have. So that's it for the housekeeping. Just to introduce myself, I'm Jon Maddy. I'm the director of the University of South Wales Hydrogen Research and Development Centre, and I'm also the academic lead for the South Wales Industrial Cluster. This afternoon's session, I'm going to give a brief introduction and overview. This is such a large topic that we can't hope to be comprehensive. So I'm just going to put a few thoughts, few observations that might set the scene, if you like. But then you're going to hear from a number of people with specific and interesting things to say about activities of their own organisation. So Tim James from Port of Milford Haven, Jeremy Smith from RWE Generation. Unfortunately, Carl Rigby from the Royal Mint is not able to join us today and apologises. So we won't be hearing from Carl, which is a shame because I know there are a lot of decent things going on at the Royal Mint in this field. And then we're going to hear from Leo Kellet at Lightsource BP. So an interesting set of speakers. And as I say, what we'll do is follow up with any questions and some answers to those. So again, if you wouldn't mind putting any questions in the chat, that would be much appreciated. So I'm going to kick off just with an overview. Many of you will have seen this this slide before, and I pull it up. So it came from Prosperity for All Low Carbon Wales, which was produced a couple of years ago now. But one of the intriguing things is it shows what and how complex our future energy system is going to be, and it encompasses all elements of electricity. There may well be a continuing role for natural gas, but that's going to be augmented with carbon capture. There's certainly going to be a role for hydrogen within that, and there's this interrelated use of power, heating and transport, and in relation to today's session, then clearly there's an industry demand within that. So potentially a much more integrated system that we'll see in future, and I think that's that's very likely to occur. The question, of course, is okay. Well, what's going to lead? Is it going to be renewable electricity? Is it going to be hydrogen? Indeed, is it going to be both? And you'll have to make your own mind up about that. But we'll see. What I'd like to try and look at is how this will impact upon industry in South Wales. If you look at the UK government's energy white paper, they put forward an illustration, and this is just one of many illustrations that suggests that demand for electricity could potentially double, and depends which scenario you look at, but that could be more than double, it could be slightly less than double. But I think it's clear that we're going to be needing more electricity as we move forward, as certain sectors electrify. And that, of course, may well come alongside the development of hydrogen, as well as a main decarbonisation vector for our industry. And my view, and again, this may not be shared by all, but certainly it's likely that a combination of both is going to occur. So much more renewable electricity alongside hydrogen. So what's clear is that there's going to be a significant impact on both our gas and electricity systems as we move towards this decarbonised system. And again, this is drawn from the same energy white paper, just as an overview, and it shows the sort of the transition from an electricity system of the past, where we had relatively few but large and relatively predictable and controllable power plants, moving towards the idea of much smaller sources but less predictability and variability with whatever renewable source that may be. An electricity network that was based on a large grid, whereas we're moving towards something that's a little bit more smart and digitally enabled. More complexity in terms of energy flows, a transition towards a decentralized and a more interconnected market system, and indeed, at least from the domestic basis, but also potentially from the industrial basis, not just customers in that sense, but potentially two-way flow where a customer may well also be a supplier at certain parts of the day. So a more complex electrical system we're moving towards. I've drawn this from the Committee on Climate Change pathway requirements, and just to sort of dissect this a little bit. And I mean, you can see how they're suggesting that to meet our carbon goals, our demand in terms of electricity demand is going to increase and continue to increase to the middle of the century, and significantly between 2035 to 2050, suggesting widespread electrification. And clearly with that, then there's a significant increase in the potential for flexible demand, and hydrogen may well be part of that activity. Again, looking at this in terms of renewables generation, current share of around about 31%, moving up towards 80% of our generation by the end of the decade. And again, the idea of dispatchable low carbon, nothing of note at the moment, but that moving to a more significant percentage by the middle of next decade. So again, you might quibble with the absolute values there, but certainly the trend and the direction of travel is I think accepted by many. And just to sort of dig beneath that to some of the key metrics, where we currently are in terms of grid intensity of around about 182 grams of CO2 per kilowatt hour, moving towards and clearly heading towards hopefully net zero. But you can see the transition and the decrease in grid intensity as we move through the decades. And I won't pick out all of these, but just in terms of offshore wind capacity, and we may well hear a little bit more about this later, but offshore wind capacity going from current value, which clearly has been a success story so far, but potentially a ninefold increase in the amount of offshore wind capacity providing electricity for the UK. I'm going to come closer to home and sort of look at some of the specifics in terms of Wales, and in this case looking at wind energy and onshore wind energy. Many of you will have seen this in the Future Wales National Plan for 2040, and these are the pre-assessed areas for wind energy. So these areas that, through assessment, in principle, should be acceptable for large-scale onshore wind development. So planning presumption in favour of that. And again, just bringing that closer to South Wales, what I've done here is sort of try to superimpose the large industrial users and indeed the large power producers in our area. And these are largely organisations that are involved with the South Wales Industrial Cluster. A couple of points to mention. I mean, just in terms of the proximity of these pre-assessed areas, in many cases, in and around Port Talbot and Bridgend, potentially there's quite close proximity between one of the pre-assessed areas. And why that's important to me is it suggests that there may well be direct linkage between some of the onshore wind developments and the industrial consumers in that area. If you look at Newport and Cardiff, probably a little bit more distance, and of course it looks small on this map, but that's a fairly significant number of miles, and even more if you look at the cluster around Pembroke and Milford Haven. Now that's just distance from onshore wind, but it may well suggest that we need to look at things like there are some opportunities, as I say, but also some challenges. So challenges in terms of grid reinforcement and thoughts in terms of how that might reflect for transition to hydrogen or even ammonia, for example, are things that we will hear about. And also, this is just onshore wind. Clearly, large-scale onshore PV is another matter, and offshore wind is and indeed tidal and other marine energies are a consideration as well. So, from my perspective, I'm going to just sort of talk about hydrogen briefly. I think there's clear acknowledgement that hydrogen is going to play a major role in our decarbonisation, and it's going to enable growth of the renewable energy sector. It's going to help to decarbonise industry, heat and transport. And there's a realisation that hydrogen is part of a more integrated energy and transport system, as I've said right at the outset. Now in South Wales, clearly there's, and I've sort of shown various iterations of this slide over the years, but essentially the point of this is to show that there's existing capability, there's existing know-how and existing production. It isn't massive. There are a number of plants, and that's useful and interesting. In terms of absolute volume, it's not necessarily that great. I've put a couple of the university facilities on there. Obviously, their production is minuscule compared to the industrial users. The challenge, of course, is that all of these are existing, apart from the university facilities, all of these are existing steam methane reforming plants. There are carbon dioxide emissions from each of those. And clearly that's something that will need to transition if we're looking to decarbonise. And so how to decarbonise? I cite this as an example of PEM electrolysis and just how far things have gone over the last decade. Back in 2011, we were working with ITM Power on what was then their first commercial electrolyser, and that's a 12 kilowatt PEM electrolyser. But over the decade, they've now indeed have announced the Refine project in Germany is a 10 megawatt electrolyser, and now the 24 megawatt announcement for a project with Linde is the world's largest PEM electrolyser. And just to give an idea of scale, that's 2,000 times the scale and equating to around about 480 kilograms per hour of hydrogen. So, and with that, significant reductions in capital cost. Capital is not everything in that respect, but I think I use this to sort of illustrate that in a relatively short space of time, there's been significant growth in the sector and maturing of the sector in that respect from an early stage R&D to a more robust commercial offering. I'm not going to go through all of this slide. Some of you will have seen this from the UK government hydrogen strategy. What it shows in general, and feel free to go and have a look at it, and indeed preferably look at some of the consultations that are out there and give your views to the government consultations on hydrogen business model and on the couple of other consultations that are out on hydrogen at the moment. I've ringed this idea the ambition by 2030 of 5 gigawatts of production capacity some may argue that we should be more ambitious, and indeed other countries are more ambitious than that. And also with that, an ambition for 40 gigawatts of offshore wind by 2030. So in terms of the way that things are going, you can see that that just over this decade, there are significant plans for deployment of both renewables and hydrogen in the UK. What that means for Wales as an industrial, and particularly South Wales, an industrial-based economy, I would argue that we should have far more than our fair share of that, or certainly a significant share of that activity. One of the challenges that we face, and if you're listening this morning, others will have mentioned this, is the absence of suitable proven geological storage for both CO2 and indeed hydrogen in this a line south of the Mersey and the Humber. And it's more difficult. So it does mean that unless we can, and there may be potential opportunities in St George's Channel, it's not clear at this stage. But as a result, therefore, South Wales has significant potential for CO2 shipping, for carbon capture and usage, and I think therefore we should lead on that. It also suggests that we should and really ought to be leading on renewable hydrogen production, and also the deployment of other vectors, and I include ammonia, for example, in that. So my hope was to give you an overview, really, of the clean energy position. I've gone down a few avenues, and I'm sure the subject is much wider than that. What I'd like to do is pass over to Tim now from Port of Milford Haven, and I'll give up control of the screen. And hopefully, Tim, if you're ready, you can take that over, if that's all right.
Thanks, John. Yeah, that's fine. I'll just start sharing my screen now.
Just while you're doing that, a reminder, for anyone, if you've got questions, please put them in the chat and we'll try and address them at the end. So over to you, Tim.
Thank you, John. Good afternoon, everybody. Tim James, one of the commercial managers at the Port of Milford Haven, west coast of Pembrokeshire. So just before I get into the meat of my presentation, just sort of give you a bit of a background about us. We're a trust port, a statutory body. We're inactive for two main reasons. We have this overarching purpose. First one is around safe navigation of the waterway that you can see here, and the second is its environmental safety. We have this kind of underlying overarching purpose in everything that we do, and it's just about ensuring the kind of sustainability, or call it sustainability, economic viability of the waterway for future generations. And we've sort of been kind of working quite hard really recently, trying to kind of think what that means to us and how we kind of come across as a business, and we kind of just put that in the bottom left of the screen here. We as a statutory body, we're immersed in this in what you see here. We're completely invested to the future of the industrial and non-industrial activity that's on the waterway, and we've got deep anchor. We can't move this waterway, so we've got this kind of anchor. We're deeply rooted in Pembrokeshire, and it is this waterway that has today it plays a really significant role in the context of the UK's energy industry. I think during the lockdowns we were bringing in about 80% of the UK's gas. I think 20% of total UK energy comes in through this waterway, and it's an industrial economy that's constantly in flux, and it's really susceptible to market conditions, not just at a local scale, it's a global scale. It's susceptible to market conditions on a global scale. Things like Fukushima had a massive impact on the activity that happened in the Milford waterway. I'll just pop these up. And it's this collective activity here. These are the major terminals that are just highlighted on here, and it's this activity that it helps to helps power our homes and businesses, provide heat and enable us to move relatively freely through public and private transport as a result. And it's all basically been located here because of the natural geography that we've got here. So, in terms of the exam question, in terms of sort of what the future is going to look like, it's really being built on the back of what you see here and the infrastructure that it's provided, and that's completely in tune with for those of you who know the UK's industrial strategy. One of the kind of the core themes in that was to put industry in a location where it's got the best ability to survive, or put nascent industry in the best place where it's got to survive. So and for a lot of reasons, that is the Milford Haven waterway, which is great when you're an energy professional living in Pembrokeshire, because it's given us as a port and me as an individual an opportunity to really drive some transformational projects, all geared up towards sort of creating the environment for future energy needs, right here in the heart of the UK's energy capital in Pembrokeshire. So what has all that activity kind of created? We've got, I'd probably say 50, 60 years worth of energy related experience in the supply chain. It's probably you can go back to the days of the Admiralty and go back centuries if you're talking about maritime maritime experience sort of ingrained in our DNA. But that's obviously a real kind of asset that we've got here, and something that should never be overlooked in terms of sort of the skill of the people and their desire to get involved in sort of future requirements. And from an infrastructure perspective, you can't have all of that industrial activity if you don't have the infrastructure that connects it. We looked at John mentioned the kind of the key kind of mini clusters in Port Talbot and in Cardiff and Newport. And when you look at the infrastructure maps, we're all connected up by pipelines, cables, and shipping routes as well. So there's some real kind of infrastructure strengths there as well. And there's also, because of the natural geography, the abundance of resource. I'll come on to some of the opportunities in a bit, so I'm not going to labour too much on this slide. And here's just a kind of a bit of a visual representation of how these assets are connected up with each other. So the natural gas that comes in from Qatar and America, can feed RWE, which Jeremy will be talking about a little bit later. And then there's transmission electric on the south of the waterway. There's mainline railways, petroleum pipelines that basically connect us up to the rest of the UK. And it's that foundation which is really kind of bringing in quite a lot of interest from third parties. A couple of them are mentioned here. They probably one of the most our infrastructure connectivity has mainly been eastward facing for obvious reasons, but we're about to embark on there's a new project coming through which will see a high voltage direct current interconnector with the west coast of Ireland, which potentially gives us an opportunity to be more outward facing and exporting energy over to Europe. This foundation has really given us an opportunity to sort of create proposals and infrastructure developments to support the needs of the kind of evolving energy requirements of us as an infrastructure provider. One of them is Pembroke Marine, which it's based in the existing curtilage of the dockyard, and the idea behind that has really been to try and create a centre of excellence for marine energy and engineering. Here, the picture you can see here is Bombora, an Australian inward investor who came in 2016-17, established themselves in Pembroke Port, and this is one of their M-Wave modules being taken from one supply chain partner to another. And it will be constructed in Pembroke Dock and then trialled in the Milford Haven waterway. And there is quite a significant resource and opportunity for the wave energy sector. There are some challenges as well, so we've got to be kind of aware of all of that when we're thinking about our infrastructure proposals. But it's it's a great project. It's been a collaborative project and something that we're really proud of, that is starting to deliver on the ground and create the type of benefit that we want. I don't think you can kind of go anywhere without sort of seeing floating wind being mentioned in terms of future energy. Here you've got the hexagon device, which they're going to be deploying in WaveHub. On the previous slide, you saw a couple of the Blue Gem wind developments being mentioned. In addition to that, since that slide was created, I think there's another 3 100 megawatt demonstration projects, and there's significant interest in scaling up for the floating offshore wind in the Celtic Sea. And obviously, as Milford Haven port and as a wider industrial cluster, there's going to be massive opportunities to support that type of activity and that energy that's created, helping us to decarbonize our industry and our economy. And as Jon mentioned as well, hydrogen, we're seeing an increased level of interest in hydrogen. And to try and help progress that, one of the projects that we're working on is the Milford Haven Energy Kingdom project. I won't speak too much about it, but it's not necessarily a technology play. We know we can electrolyse, we know we can put it in a car and drive a hydrogen powered car. We know we can store it, we know we can pass it in a fuel cell to create baseload. But what we need to understand, and what we need to help kind of key decision makers understand, is what market mechanisms need to be in place to unlock the use of hydrogen at a local level for use in our heat, power and transport systems. And that's really what the Energy Kingdom project is about. It's a market mechanism play. And although it's focused on a local level, we're completely aware that the big opportunity is those big industrial players that are ingrained in the Milford Haven waterway, the likes of RWE, Polaris, and Dragon, and what market conditions they will need in order to really kind of ramp up their use of hydrogen, whether it's green or blue as a transitionary technology. So I think that's kind of where we see it going in terms of the technology. And I think that the question and the challenge that I think we've got is how do we, as Milford Haven Port Authority and as South Wales Industrial Cluster, how do we maximise the opportunity, not just in terms of the adoption of the technology, but how do we set ourselves up to create those long-term job opportunities for our young people? There's ability for our supply chain to get involved in those industries and win business and create the kind of economic growth that certainly government want to see in terms of sort of levelling up and building back better and all those good things that are in the in the 10-point plan. For us as a sport, we're not the biggest organisation, and we've got limited resource, so we have to collaborate. And that's the great thing about the South Wales Industrial Cluster, is that we get to collaborate with like-minded people, and we can we can use the roadmap project to help understand what's coming and when it's coming, so that we can deploy our resources as effectively as possible. The same with the deployment project, which is a little bit more sort of blue hydrogen focused. We get to use involvement in that project as an opportunity to understand the environmental and navigational impacts that blue hydrogen and carbon capture and storage shipping will have on the waterway, and how we need to prepare as a statutory body to respond to that and prepare for that. So it's a really interesting time to be an energy professional, and I think generally looking forward to what the next certainly the short term is gonna hold. But yeah, it's going to be a big challenge and a long challenge, which I think for everyone at the Port of Milford Haven, we're really looking forward to. That's my presentation, Jon.
Tim, that's fantastic. Thank you very much. And if there's any questions for Tim, please put them in the chat. We're going to move on to Jeremy Smith from RWE Generation. So thanks very much, Tim. Jeremy, if you're okay to share your presentation, then please go ahead.
Yeah, I'm working on that now.
No problem. If you're ready,
you
then
can
that's
see
fine.
that.
Yeah.
See that.
Yeah.
Excellent. I won't be able to see if anyone puts their hands up or anything. I'll just try and blow this up a little bit. Unfortunately, I've been stuck in my bedroom for the last 6 days with COVID, and I'm starting to go slightly mad from the isolation, but bear with me. I'll do my best. Hopefully you can see that.
Jeremy,
Sorry,
could you go into slide mode, please?
Yeah, sure.
Yeah.
That okay?
That's great. Yeah. Thank you.
No trouble. Yeah, so I'm the Hydrogen Regulatory and Subsidy Manager for RWE, which is a role I've been doing since July. We've got a small hydrogen team within RWE. It's about 42 people at the moment, looking to grow. That's worldwide. We've got a number of core markets, UK being one. Before that, I was the onshore wind development manager for Wales for RWE. So we developed a portfolio of projects that have built out across Wales, and colleagues carrying on that good work after I left. So I'm also more than happy to talk about issues around onshore wind, maybe that slide that you mentioned from the National Development Framework showing the areas, priority areas. I could talk to that if you want, if you ask me a question about it. Just there's always a little bit of a pitch at the start, isn't there? So, you know, a bit of explanation about us for those that don't know. I mean, RWE is a huge company. We're a power generator. We've got renewables. We've got conventional power stations, and we'll come to that. You know, effectively, we've got a worldwide profile, big obviously in Europe, but also in America now. So I will just move on. One thing that we have done recently is we've set a clear goal or direction of travel to be climate neutral by 2040. So we've committed to a robust set of science-based targets around this, aligned with Paris, the Paris Agreement. We aim to be carbon neutral by 2040. We've started that transition away from fossil fuels already. For example, you'd probably be aware the Aberthaw coal-fired power station near Cardiff closed down in 2020. We've already reduced our CO2 emissions by about 50%, but we've got a long way to go towards net zero. The targets themselves are independently affirmed by the Science-Based Targets Initiative, and as I say, they're in line with Paris, and we joined the Race to Zero initiative. This is a slide that kind of shows just our activity in the UK, really. So what you've got there are different coloured dots for different types of infrastructure, be it offshore wind farms, offices, onshore wind farms, hydro businesses, biomass plants, and gas-fired power stations. And you see the Pembroke one there. It just gives you a flavour of our spread across the UK and the amount of activity that we're involved with. In Wales, our total installed capacity is 2.6 gigawatts. Largely the gas-fired power station at Pembroke, but also offshore wind, onshore wind and hydro. And we are Wales's largest power generator and operator of renewables, but also power. Talk a little bit about height, and I'm conscious there's a little block here. I don't know if I can just remove that. Right, that's gone. Hopefully you can still hear me. Right, this is just saying about the sort of value chain for hydrogen, and I think this is where we as a company can kind of contribute in an awful lot of areas, because we're you know, we're a company that spans that whole value chain. So on the one hand, we produce renewables, and renewable power powers green hydrogen. But we can also potentially be at the far end an off-taker of hydrogen and use it to power our power stations. So we're potentially customers of people creating hydrogen. In the middle, we can supply and trade and store and distribute hydrogen. So that's also something that we can do. We've got a target internally of approximately 2 gigawatts of hydrogen production by 2030. Just give you an idea again, we've got a portfolio of projects across the world, and many of those aren't in the UK, but they do span across the value chain. So some projects, they cover the electrolyzer and logistics, others will be included with renewables, some will be included with the use of hydrogen. So just to give you an example of that. What I really want to talk about today is the Pembroke Net Zero Centre. So this is, if you like, an umbrella term or a phrase for a concept that brings together as a sort of centre of expertise at Pembroke, people within the broader company to deliver initiatives that decarbonise, centred around the Pembroke area. So we've got the conventional power station, which you can see there. We've got floating offshore wind. We've got an electrolyzer, and that's really the three themes of it. What we have effectively is the Pembroke Net Zero Centre is if you like the UK's transition to net zero writ small. It's what we've got to do right across the UK, we can do in one place in Pembroke, and that's why we chose that site and that name. So we've got kind of three pillars of activity, really. There's the decarbonisation of the power station itself. There's the offshore floating wind opportunity in the Celtic Sea, and there's a green hydrogen production project. Excuse me a minute, my dog's just raided the bedroom. Out. Sorry about that. That was my dog. She just raided the bedroom and jumped on the bed. So sorry about that. And I think where we are with that, it kind of what we're doing at Pembroke also sort of supports other activity that's going on. So that's what you've got on the left hand side of this slide, really. So there's interactions outside of RWE activity that are also relevant, and we support, and it supports us. So South Wales Industrial Cluster is part of that. Milford Haven Energy Kingdom that Tim mentioned. Another piece of activity locally looking at hydrogen. So that's important. We've got the Crown Estate. We've got, if you like, Welsh Government, UK government policy that's also relevant. National Grid, gas transmission, the distribution level gas and electricity grid. We've got industrial off-takers, Welsh Government activity, the lot, really. So, I think what we would say there is Pembroke Net Zero Centre is not just an internal RWE initiative, it's also outward facing and helping to complement other initiatives. Everyone likes an infographic, and I would be remiss if I didn't have one as well. So what this tries to do is to set out in a way that kind of big picture interlinkages between all the various activities of Pembroke Net Zero Centre. So you've got everything from locally sourced direct connected renewables that could be linked to an electrolyzer that could then export to local off-takers, the power station, into the gas grid. You've got the opportunity later on of floating offshore wind, potentially either connecting directly to the national grid electricity system or potentially creating hydrogen and putting that hydrogen into the grid infrastructure system. You've got the potential for Pembroke Power Station being decarbonised and the shipping of carbon dioxide to storage elsewhere in the world. So it kind of this sort of tells the story of everything that could happen. It's not to say it necessarily will all happen, but the idea is, you know, that's what we're working on, and as much of it as can be done will be done, I think. Why Pembroke? This is really about, you know, why is Pembroke a good location for this kind of centre and this activity? And I've mentioned some of it, but effectively we've got a gas-fired power station that needs to be decarbonised. There's the opportunity for the Celtic Sea offshore wind right on our doorstep there. There's a number of decarbonisation projects for the South Wales industrial cluster who could be users of hydrogen. We've got work on Milford Haven Energy Kingdom that's relevant. We've got potential suppliers of blue hydrogen in the vicinity. There's deep water port, which may be useful for moving CO2 or for shipping hydrogen about. We've got power grid, we've got the gas grid, and both of those are on site. We've got, as I say, potential off-takers for green hydrogen as well. Then I think I mentioned we had 3 pillars to this activity. The first one is the firm, flexible, low carbon power. So this is effectively decarbonising the 2.2 gigawatt power station at Pembroke, which is a gas-fired power station. It's one of the UK's most efficient gas-fired power plants. It's got the lowest level of CO2 production per unit of electricity. But I think the challenge is it needs to be a net zero power station in due course. And I think you've probably seen on the news the announcements that Boris Johnson is soon to make around, you know, taking gas out of the power system by 2035. So, you know, clearly that is a pressing issue, and it's something we're going to have to get to grips with. So we've started to work on that with our colleagues in SWIC. And really what we're looking at this stage is a number of feasibility studies looking at the partial replacement of natural gas with hydrogen to reduce emissions. So maybe 15% of that gas going into the plant being hydrogen. So that's a technical study we're looking at. 100% replacement of the gas by hydrogen, and also looking at carbon capture and storage opportunities around the site. So the next stage is to carry on with those work and then move into a second phase of further, more detailed studies. In terms of pillar 2, this is the Celtic Sea floating wind. So basically us alongside you know, a large number of other developers see the opportunity for floating wind. It's clearly something that is going to need to ramp up, as you know, the opportunities for fixed bottom offshore wind are increasingly taken up and already developed. Then you're going to need to move to floating to replace that fixed bottom offshore wind that you've effectively run out of space for. So, you know, it's something we need to look at. There's only so many good places around the coast of the UK to do it. The Celtic Sea has been identified as one of those. I was at the launch of the Celtic Sea cluster last week, and it was very interesting. I think there was talk of maybe up to 100 gigawatts or so of floating opportunity within the Celtic Sea, and talk of about 10 gigawatts or so within Welsh waters off the coast of Wales there, which is great. Now that is a real opportunity locally, because it is off the shores of Pembrokeshire there, and having, you know, the grid on site is obviously an opportunity for us, and we're a floating developer, so we're interested in that, as are any other number of people. So I think the next stage really on this is that the Crown Estate is going to have a process for allocating early commercial scale floating wind opportunities in the Celtic Sea, and we, alongside other people, are sure to respond to that tender. So we've got people working on those kind of projects now. The final stream really is around green hydrogen. So what we're doing here is we're looking to develop green hydrogen projects in the vicinity of the Pembroke power station to use renewables, and that could be grid connected or locally direct wire connected, to then run an electrolyzer, create green hydrogen, and then sell that green hydrogen into industrial users of hydrogen in the South Wales area. So we've got a team working on that, and we're working on this project at the moment. We're just about to engage on the feasibility work for that project, which again is working with SWIC and funded through SWIC to start to do the feasibility work on developing those projects. And what we're looking at is, you know, initially a lighthouse project, if you call it that, because it shines the way. You know, that may be as small as 20 megawatts or so. We're thinking more like 100 megawatts, but it may be even bigger than that. And I think that one of the purposes of the feasibility is to establish, well, actually, how big should it be? What are the constraints that define the shape of that project? So we're working on that. But what we will also do is look to the long term. And in the long term, you're talking about large scale production linked to offshore floating wind in the Celtic Sea. So potentially a gigawatt of scale or gigawatt scale projects, which are then looking to inject hydrogen potentially into the gas grid, either for blending or into a repurposed gas grid as part of the UK hydrogen backbone. So that's the green hydrogen element of the project. There's kind of two steps to that. One is the feasibility work, which is just about to start and should be finished just after Christmas, but also consideration of the questions around where do we get our renewable power from to make sure that it's green. The final slide really is this one, which is trying to pull all these strands together into one kind of timeline or roadmap, just to kind of demonstrate, well, how do we get from where we are now in the early 2020s to 2040 or so, and decarbonised sort of Pembroke. And what we've effectively got is, you know, start small, build up. So with the green hydrogen project feasibility study, initial stage for the lighthouse project, scaling up, and then eventually gigawatt scale deployment. And it's effectively the same story through with the Celtic Sea, with early commercial tenders and building those out, and then moving into, you know, full scale gigawatt scale floating wind projects. And then the power station itself, its initial studies, agree the plan for decarbonisation, start to implement the plan, and then eventually decarbonise the site. That is it for my presentation.
Fantastic, thank you,
Thank
Jeremy.
you. I'll stop. I'll turn this down now. Right, thank you.
Sterling effort coming from your COVID sickbed, so thank you for that.
Yeah, sorry about the interruption from the dog.
No problem. So we're going to turn to our final speaker, who is Leo Kellet from Lightsource BP. Thanks for the questions. What we'll try and do is get to those at the end. I think I sense with timing that we may well go over our allotted hour, but I think we'll have to try and address those questions as soon as Leo has finished. So Leo, over to you.
Hi there. I think we'll be okay for time. I've only about 5 minutes of material here anyway. So yeah, Lightsource BP. We've been involved with SWIC now for a while. We are obviously a solar power developer, so that's the expertise that we're bringing hopefully to it, and that's the kind of area that we deal with. But a bit about Lightsource. So we started back in going on 2013, 2012, perhaps no, about 10 plus years actually. I only joined in 2015, so I think about 2010. We did a joint venture with BP a few years ago. It's now a 50-50 fully joint venture. So BP, some of you may be familiar with, had a fully owned solar arm back in the early 2000s. However, they were doing PV module construction, which then really kicked off in China and just killed BP's solar ambitions. So we're a leading solar power developer in about 15 countries. Our pipelines got very large very quickly in the last year and a half. We recently announced some very large funding requirements have been hit, and we laid out a new pipeline which I think is something around 25 gigawatts by 2025 of solar power, and that's all over the place. That's United States, UK, Australia, Portugal, Brazil, Italy, Spain, perhaps Poland as well, and some of that's working with BP as well near some of their sites, but a lot of it is just what we've been doing for the last 10 years, which is turning up to a field, getting all the planning and everything in place, and building a solar farm and exporting the power to the grid. So we do everything from develop the site, to managing and operating it, to owning and selling it. So we have an asset management team, on a operation and maintenance team. With the developing, we've got a whole finance team that go out and get, because these are all done on project finance, so we'll go and get finance and lenders for that. We have a whole in-house technical team to do what we call 70% design. So when it comes to the actual engineering, procurement and contracting, the EPC work, we don't actually do that. So we don't do exactly where the cable trenches is going to go. We don't go and subcontract the trenches and stuff like that. We use an EPC, engineering, procurement and contracting company. So we do everything except for the actual physical building of the site. And as I said, it's a global company. So UK, Netherlands, we had a joint venture in Egypt, which is going okay. There is Eversource Capital in India, which is a joint up between Lightsource and a financial institution over there to invest in solar power, and we have some smaller sites in Trinidad and Tobago. We're just getting into Taiwan at the moment, but the real big ones are in Europe, United States and Australia, especially Australia and the United States, because obviously a lot of land there. So as I kind of mentioned previously, the structure is vertically integrated, legal, planning, finance, everything inside the company. So we do everything except for actual construction, and that we own the plants. But from a SWIC point of view and a hydrogen point of view, we're not just what is jokingly said is a finance company with a bit of engineering. We have a real core engineering team, which has grown massively over the last few years. And so we have a central engineering team with experts in specific areas: electrical engineering, civil engineering, mechanical engineering. And then we have regional engineering teams as well to make sure that all these plants are being designed and built up to good spec, because we're going to own them for 30 plus, going on 40 years if we can get the leases for. So we want the things to stand the test of time. So on the innovation front, which is the team who's working with SWIC, because obviously hydrogen is not our usual bread and butter, we've always had a bit of innovation going on since 2015. So the fact that solar power, you can't control your resource, and the margins perhaps not as tight as oil and gas, means that any small increase you can get in your efficiency and therefore your power out is very, very useful, because you can only get that sunlight when you have that sunlight. So one of the first big innovations we did was getting at the time Europe's, and at the time the world's, largest floating solar park developed in the Queen Elizabeth II reservoir, which is that picture there. It was Europe's for I think a good half a year, and it was the world's I think for about a week, because then one in China got commissioned that was about 20 times the size of it. Other innovations such as back panel optimizers and bifacial panels. We've also tested bifacial panels, are the two-sided panels where light can enter both the front and the back. That's now industry standard, but we built a site with bifacial panels years ago in Northern Ireland that helped us be very confident moving forward with them. We now have a dedicated team, an innovation team, of which I'm a member, And it's these projects like green hydrogen, improving the albedo, hail damage mitigation, and creating reactive power at night, which come under this innovation team scope. And because we're an innovation team, not just in a kind of consultancy role, but actually within a developer, we have loads of sites that we can experiment on, loads of data that we can use. I say good data for half a decade because some of the earlier data from when the sites were originally built, not that great in terms of coverage. And it's this good data that this data and this background that we've leveraged into SWIC, because in Wales we already have several solar power sites, and we've used the data from those solar power sites to help model how renewable power can have a relatively smooth production output so that we can get a relatively smooth hydrogen output. We do like to keep a lot of links to industry in the innovation team, both through our core business as a solar power developer, but also through BP. And we're always trying to make more academic links. So working with the university has been really useful on this project, and coming up and seeing the electrolyzer like we did a few weeks ago. And the area of interest for our innovation team, which SWIC and green hydrogen really falls well into, is not R&D. So if it's very early days, so something like perovskite is definitely on the horizon, but it's not something, unless we can have a couple or a few dozen of the kit or whatever it is, whether it be a new kind of bifacial panel or a new kind of optimizer, or even a new kind of robotic mower that we have at the moment. Our focus is industrialization, so testing this kit out, getting it bankrolled, and getting it from that kind of end of R&D working prototype to being rolled out across the whole portfolio. So what we've been doing in SWIC and green hydrogen has been very interesting, because SWIC has been a real first kind of look for us into green hydrogen, which is very needed for us because we've actually have some projects on the continent where we need to be making hydrogen relatively soon. And with our experience in modeling renewables and previous experience with solar and wind co-location and solar and gas turbine power generators, this has really helped with the modeling of effectively what we're doing in work package 10, which is, we have a solar power output, a wind power output, and how can we combine these two with the efficiency curve of an electrolyzer to work out how much hydrogen we can actually get out for how much energy we're putting in. I mean, that's the core of what really our place in this is, and it's the core of what I'm doing. There's also some financial modeling as well. What are the key challenges at the moment for this project and in general I see for moving forward with green hydrogen is the similar challenge we actually had with putting a solar farm next to a gas turbine generator and seeing how much gas we could offset, is good information from the manufacturers of the kit. So for the electrolyzers, talking to the industry, there's been a lot of companies and developers like ourselves kind of dipping the toe in the market, doing feasibility studies and things like that. So they're getting a lot of knocks on their door, and I think they perhaps don't take all of them as seriously as others, and there's also not a huge amount of third-party qualified lab data. So getting the key technical parameters from these electrolyzer manufacturers has been one of the struggles so far, but the first movements in this have been really positive. South Wales in general, our plans in general for South Wales are, other than SWIC and green hydrogen, build more solar plants. I mean, that's what we do. Panels in the ground, as it were. So we already have another large conventional plant coming in Wales. We already have quite a few existing plants in South Wales, and you can see why on this irradiation map here. Whilst the best irradiation is kind of southeast of England, South Wales is pretty good as well. It's a reasonably narrow strip, but it's pretty good as well. And also with South Wales, there's a lot of industrial and corporate power requirements and private wire PPAs, which is where they build a site next to your site and put a wire in is always a good way to go. And grid is generally pretty good in South Wales because there's already a lot of power generation and a lot of power users already there. So that's our kind of South Wales plan. Is as with everywhere, more solar power, more renewable energy. Thank you for listening.
Fantastic. Thank you, Leo. And well, we're right on time, but I'm aware and conscious that I promised that we would try and address some of the questions. So obviously, hopefully you've enjoyed the session. If you want to follow up with any of the questions, then please get in touch. But if the presenters are okay, and if you, as the audience, can stay on, we'll try and address some of the questions, although we'll do it briefly if that's okay. I've tried to pick up on one or two of them already. Can we go to Dave Richardson's question, which is, do we have a vision of South Wales being a net provider of green and blue hydrogen for the rest of the UK and further afield? I've got a view. Anyone else like to chip in, though, before I...
I'd say vision, yes. Plan, it's coming through roadmap. And that's where I probably see the detail kind of coming through in terms of the scalability and the size of the prize. And I think the next couple of years, while roadmap's happening, is going to be quite interesting in terms of some of the market developments in terms of hydrogen policy, floating wind, revenue support, those sorts of things. So yeah, I think vision, yes. The detail will come.
I think if I was going to make my point on it, we've got quite a lot of demand, industrial demand anyway, which we need to sort out. So in the long term, yes, and I think really it's probably linked to the fact that there isn't the sufficient grid capacity to exploit the full Celtic Sea floating offshore wind opportunity within Welsh waters. So realistically, it might well be easier to turn that into hydrogen and put it into a repurposed hydrogen transmission grid than it would be to build new grid infrastructure.
Thank you. Leo, wondered if do you have a view on that?
I mean, I don't know a huge amount really about the other than a possibility of, as I say, more solar production to help with the hydrogen production. And certainly, if there is a push towards a higher demand from that, then there will certainly be a push for more renewable energy generation.
Okay, thank you. Question specifically for Jeremy. Can you ever see a scenario where green hydrogen will be used for power generation in the Pembroke CCGT rather than using renewable electricity as electricity?
Yeah, it's an interesting one, that. I mean, I could certainly see a scenario where hydrogen will be used, whether it's green or blue, is probably a moot point depending on the economics of how much it costs to generate and when green overtakes blue in terms of its cost effectiveness. So yes, hydrogen, definitely, green, possibly. I think, the other question there is around, okay, how do we transition that power station across to hydrogen? Hydrogen might not be the best option for it. It might be post-combustion CCUS. So that's another consideration. Also, what happens with floating wind and how you get that potential away, given the constraints on the grid system, again, might say, well, there could be a lot of hydrogen in the gas network in Pembrokeshire. So, yeah.
The thing that's really impressing me is 5 years ago, these questions might have been, a bit speculative. Now, at least with SWIC and related activities, we're looking in earnest at these sort of things, which I think is all valuable. next question, and first come, first served on this, is how can the region become a source of energy storage? And we'll try and roll them up together. How do we keep the carbon footprint of floating offshore wind low? So any thoughts on either or both of those?
Being pretty selfish from the port's perspective, locating the supply base as close to the offshore wind farms as possible would certainly have a significant impact on its operational CO2.
Okay. And in terms of source of energy storage, one of the challenges for us is that large scale storage, but I do wonder, thinking specifically of some of the things that we've discussed with Lightsource BP about ammonia production, renewable or green ammonia production as a potential storage mechanism and or vector, then these things are under consideration, I suppose, and we have some disadvantages and we have some advantages, I guess is the way I would put it. We've got to start to work out both the technical, economic and environmental impacts of each of these things.
And storage will be required. I mean, just one other point on the carbon footprint point is obviously, it's the whole economy that needs to decarbonize. Not just the power sector, and power sector's actually made probably more advances than many other sectors, but cement, steelworks, etc. They're also on a trajectory to decarbonize. So the faster and harder they can work to do that, then that does start to reduce the carbon footprint of things that are made from those products. So I mean the key issue is still better. There is some carbon footprint associated with your project, obviously, but the sooner you've got a kind of payback in terms of carbon compared to using other power sources, then the better that is, and the lower carbon that you can make the supply chain, then obviously the better that is as well. So there's a kind of we're all in this together approach, I think.
Thanks very much. Helen, your question about the convergence or alignment between the Zero 2050 project findings and what SWIC are doing. So as well as we can, we're going to incorporate the analysis that Zero 2050 have done. For those that don't know, that was a National Grid-led project, but had a heavy engagement from a number of SWIC partners, including WWU, WPD. And I'm very mindful in this respect of the report that Regen did for WPD and WWU, which looked at a number of scenarios and was a very thorough piece of work. So it's certainly high on the agenda of things that we're trying to incorporate, and similarly, we'll be developing new plans alongside that as well as we learn more. And then I guess the final question is just role of green oxygen. I mean, it's interesting, of course, if we do go for a large scale, green hydrogen, then there's co-produced and typically very pure oxygen being produced alongside that. I have to say, because that was my old industry, it's not on the face of it going to compete with air separated oxygen because there's only separation from air to do. But on the other hand, as co-produced oxygen, so if you're making the hydrogen anyway, then the economics may well be beneficial. I think it'll depend on location, it'll depend on scale, and it'll depend on the infrastructure that comes with it. So if it's co-located so that, for example, we're looking at some things within the water industry where you might co-locate both hydrogen production and oxygen and use both within a short distance, then the economics of that are going to be better than if you have to take one of those products and export it by pipeline, by tanker, by whatever. But yeah, it's a big question, and often in the economic analysis of hydrogen, it's missed out. So I think it's something we should incorporate. I think that's probably answered all the questions, certainly all the questions I can see. And we've run over, but for me, it's been a really interesting session, and I've really appreciated the the presentations from all our presenters. So thank you, gents, for that. I hope our audience has found that as interesting. And there's another session tomorrow, so we go again. Thanks very much to everyone, and
Thank you, everyone.
Thank you. Bye-bye.
Bye.